polymers. So the polymers are coming from the word macromolecules. So all of you know what is macromolecules. So macromolecules are very large molecules. The small molecules are combined to give the big molecules. So they are called as a macromolecule. The small molecules like carbon, hydrogen, sulfur, nitrogen are combined to give the big molecules that are called as macromolecules. So what are the types of macromolecules? Lipids, carbohydrates, proteins, fatty acids are the types of the macromolecules. So the types are called as, is called as biomolecules. So the biomolecules are called as lipids, proteins, fatty acids, carbohydrates. So example for the macromolecules are synthetic and natural. So the natural is example, all of you know that silk, wool are that example for the natural fiber. Whereas the synthetic are what we are here, the nylon, that are the example for the synthetic. And mainly used for the various application in the industries like leather industry, plastic industry, fiber industry, elastomers. So that polymers, the word polymers is coined in the year 1833 by Jones Jacob. So the polymers is coming from that word, that is Greek word, is coined in the year 1833 by Jones Jacob. So all of you know what is poly and what is mer. So poly means is many, and mer is units. That is, units are parts. So that is called as a polymers. And what is a polymerization reaction? So what is polymerization reaction mean? Is first point, it is a chemical reaction. The small molecules are combined to give the big molecules. Our monomers are combined to give the polymers. And with or without elimination of small molecules like water and HCl is called as HCl is called as polymerization. So polymerization is monomers are combined to give the polymer with or without elimination of small molecules like water and HCl. The next one, degree of polymerization. Degree of polymerization, the term is defined as number of repeating unit in a polymer chain is known as degree of polymerization. That is, degree of polymerization is denoted as dP. dP is a degree of polymerization. The number of repeating unit in a polymer chain is known as the degree of polymerization. That is, dP is equal to molecular weight of polymeric network divided by molecular weight of repeating units. So this is called as a dP. So dP is the degree of polymerization. The number of repeating unit in a polymer chain is known as degree of polymerization. That is a molecular weight of polymeric network divided by molecular weight of repeating units. The next one, we will discuss about functionality. So what is functionality? The number of bonding site and reactive site present in the monomer is known as functionality. That is the number of bonding site or reactive site or functional group present in the monomer is known as functionality. So what is the example for functionality? example is functional group and functionality. So we take the first example is acetic acid. So the function group is carboxylic acid. So the functionality is 1. So why we are putting as a 1? So what is functionality? How many numbers of bonding site or reactive site or functional group present in the monomer is known as functionality. So here one carboxylic acid, one functional group is there. So that we are telling us functionality is 1. And another example. So this is hexamethylene diamine. Here functional group, there are 2 functional groups are there. So here for acetic acid, the carboxylic acid is 1 functional group. So if we are telling as a functionality is 1. Here there are 2 amine groups are there, hexamethylene diamine. So 2 amine groups are there. So we are telling as functionality is 2. So for this example, glycerol. Here how many functional groups? There are 3 functional groups, that is for OH group. So the 3 functional groups are there. So we are telling as functionality is 3. And another example, CH2 double bond CH2. So there are 2 reactive sites either on that double bond. So the functionality is 2. Here that reactive site is double bond. So the reactive site we are telling is a double bond. So there are 2 reactive sites. So that is called as set. Functionality is called as set 2. I think it's all of you clear about what is functionality. Functionality means it's mere number. So how many number of bonding site or reactive site or functional group present in the monomer is known as functionality. The next heading will see the tacticity. So tacticity, the word derives from the Greek word. So the tacticity means tacticity or stereospecific polymer. That is, the word tacticity is derived from the Greek word. It is called as arrangement. Arrangement or order. So what is defined tacticity? So the orientation of monomeric unit or functional group, either orderly arrangement or disorderly arrangement with respect to main chain is known as tacticity. So the tacticity, the word is derived coming from the Greek word. So what is tacticity means is arrangement or order. So what is the definition of tacticity? So the orientation of monomeric unit, either orderly arrangement or disorderly arrangement with respect to main chain is known as tacticity. And next we see types of tacticity. So there are 3 types of tacticity. Isotactic, symbiotic, and atactic. So there are 3 types of polymer: isotactic polymer, symbiotic polymer, atactic polymer. So arrangement of chain. So the tacticity means arrangement, either orderly arrangement or disorderly arrangement. So isotactic polystyrene, symbiotic polystyrene, and atactic. So now we have to discuss about that. Example for isotactic. Isotactic example. Styrene undergo the polymerization styrene undergo the polymerization, we can get isotactic polystyrene. This is called as isotactic polystyrene. So what is isotactic polystyrene? So the functional groups are arranged same side of the main chain is called as isotactic polystyrene. Example is styrene undergo the polymerization, we can get isotactic polystyrene. So second one is symbiotic polystyrene. So symbiotic polystyrene, we are taking the same example, styrene undergo the polymerization. We can get symbiotic polystyrene. So what is symbiotic polystyrene? The functional groups are arranged alternating side. It is called as symbiotic polystyrene. So previously we have studied about the isotactic polystyrene. That the functional groups are arranged same side. Here for symbiotic, functional groups are arranged alternating side is called as symbiotic. And the third one, atactic. So atactic polystyrene, we are taking the same example, styrene undergo the polymerization. We can get atactic polystyrene. So atactic polystyrene, so the arrangement is random arrangement. It's called as atactic polystyrene. So far we have discussed the three types: isotactic, symbiotic, atactic. So what is tacticity? Arrangement of functional group, either orderly arrangement or disorderly arrangement with respect to main chain. So isotactic means the functional groups are arranged same side to the main chain, whereas the symbiotic functional groups are arranged alternating side of the main chain, whereas atactic functional groups are arranged randomly. So that is called as tacticity or stereospecific polymer. So tacticity is coming from the Greek word. It is called as arrangement or orderly or disorderly arrangement. So that is we are taking as styrene undergo the polymerization. We can get any three type, either isotactic or symbiotic or atactic. Next we will see the classification of polymers. So polymers cannot be classified under any one category because of their complex structure and different behavior and vast application. So the backbone of that polymer is mainly for carbon chain. Mainly backbone of the polymer is contained, the linear backbone is contained only for the carbon chain. Because of the complex structure, different behavior and vast application, the polymers cannot be classified under one category. So based on RG, polymers are classified into three types. natural polymer, semi-synthetic polymer, and synthetic polymer. There are three types of polymer. So based on it RG. So natural polymer is derived from naturally occurring of plants and animals. Example, so protein, lipids, that is the biomolecules. So carbohydrates are natural polymers. So they are occurring naturally derived from the plants and animals. Example is biomolecules, proteins, carbohydrates, lipids are called as natural polymers. Semi-synthetic polymers, they are derived from naturally occurring polymer and further chemical modification is taking place. So example is nylon, synthetic rubber, polyvinyl chloride. So there are examples for semi-synthetic polymer. Synthetic polymers are man-made polymers. Example is plastic. So that is based on origin. We are telling as natural polymer, semi-synthetic polymer and synthetic polymer. So natural polymer, they occur naturally found in plants and animals. So they are called as a natural polymers. So example are called as a biopolymers, protein, lipids, carbohydrates. Whereas the semi-synthetic polymers, they are derived from naturally occurring polymer and further chemical modification takes place. So example is rubber, synthetic rubber. And synthetic polymer is man-made polymer. Is example is plastics. And the next one based on nomenclature. So based on nomenclature, polymers are classified into 5 types. Homopolymer, heteropolymer or copolymer, homochain polymer, heterochain polymer, and stereospecific polymer. So there are 5 different types of polymer based on nomenclature. Homopolymer, heteropolymer or copolymer, homochain polymer, heterochain polymer, stereospecific polymer. Already we have studied stereospecific polymers are called as tacticity. So what is homopolymer? So the monomers are arranged same type is called as homopolymer. Homo means same. So same type of monomer is called as homopolymer. Example is polyethylene. So depending upon the arrangement of monomer, there are 3 different types of homopolymer. Linear homopolymer, branched homopolymer, and cross-linked homopolymer. So depending upon the arrangement of monomer, so there are 3 different types: linear, branch, and cross-linked. So the linear arrangement is same type, M. The monomers arranged linearly is called as linear homopolymer, and the branched homopolymer, so one is a main chain, so M is called as a monomer, another one is a side chain. So this is called as a branched homopolymer. And cross-linked homopolymer, so the chains are linked cross. So the main chain of the monomers is a polymer chain. So the linking takes place is a cross-linking. So the cross-link arrangement is known as cross-link polymer. So the homopolymer, what is homopolymer? cross-linked polymer. So the homopolymer, what is homopolymer? Homo means same. So same type of monomer, MMM, is called as polyethylene. Example is polyethylene. So based on arrangement of monomers, there are three different types: linear homopolymer, branch homopolymer, cross-linked homopolymer. So how is it arranged? Linear homopolymer is a linear arrangement. So the branch homopolymers are arranged. One is a main chain, another one is a side chain. So like this is called as a branch homopolymer, and the cross-linked homopolymer. So that the polymer chains are linking by cross. So cross-linking, so it is called as a cross-linked homopolymer. Second one is a heteropolymer or copolymer. So hetero means is a different, so different monomers. More than one type of monomer. So same type of monomer is called as a homopolymer. Heteropolymer, more than one type is called as a heteropolymer, or otherwise is called as a homopolymer. So that is M1, M2, M1, M2 is called as a heteropolymer. Example, nylon. So based on the arrangement of monomer, the heteropolymers are three types. So heteropolymer or copolymer. So based on the arrangement of monomer, that is a random, log, graft. It's a random copolymer, block copolymer, and graft copolymer. So based on the arrangement of monomer. So hetero means is a different monomer. Homo same type of monomer. So heteropolymer or copolymer, more than one type of monomer. M1, M2, M1, M2 is are called as heteropolymer. So based on arrangement of monomer, there are three different type of heteropolymer: random, block, graft. So random, example for random: M1, M2, M2, M1, M2, M2. So random arrangement, that is called as a random copolymer. The monomers are arranged randomly, and a block M1, M1, M2, M2, M1, M1, like this. That is called as a block. M1, M1, M2, M2, M1 arrangement is called as a block. And the graph arrangement, M1 is a main chain and M2 is a side chain. So that is called as a graph copolymer. So second one is a heteropolymer or copolymer. So hetero is a different type of monomer, M1, M2, M1, M2. So the example is nylon. So based on arrangement of monomer, there are three different types: random, block, graft. So random means is randomly arrangement of the monomer. Block means is M1, M1, M2, M2, M1, M1, M2, M2. That is called as a block. And the graft, M1 is a main chain and M2 is a side chain. Next one is a homo chain polymer. So homo chain, the main chain of the polymer is made up of same species of atom. That is carbon, carbon, carbon. Same species of atom is called as homo chain. Main chain of the polymer is made up of same species of atom. Example, polyethylene. So polyethylene. And hetero chain. Hetero means a different. So the main chain of the polymer is made up of different atoms. Example is carbon, oxygen, nitrogen, carbon. So different atom. The main chain of polymer is made up of more than one type of atom. Carbon, oxygen, nitrogen is called as hetero chain. Example is nylon. And the last one, fifth one, is a stereospecific polymer. So stereospecific polymer or tacticity already we have studied. So that tacticity means arrangement, order. So the function groups are arranged either orderly or disorderly arrangement is called as stereospecific or tacticity. There are three types: isotactic, symbiotic, atactic. So isotactic means same side, symbiotic means is alternating side, and atactic means is a random. That is called as a tacticity. So based on nomenclature, polymers are classified into homopolymer, heteropolymer or copolymer, homo chain polymer, heterochain polymer, stereospecific polymer or tacticity. So homopolymer means same type of monomer, M. So based on arrangement of monomer, there are three different types. So what are the three different types? Linear, branch and block. So that linear cross-link. So linear arrangement, monomers are linearly arranged, and then a cross-linking arrangement and branch. Branch means one is a main chain, another one is a side chain. And heteropolymer or copolymer, more than one type of monomer, M1, M2, M1, M2. Example is nylon. So based on arrangement of monomer, there are three different types: random, block, graft. So random arrangement and block means M1, M1, M2, M2, M1, M1 is known as a block arrangement, and graft is M1 is a main chain, M2 is a side chain. And homo chain means the main chain of polymer made up of same species of atom, carbon, carbon, carbon. Example is polyethylene. Hetero chain, the main chain is made up of more than different type of atom, carbon, oxygen, nitrogen, carbon. That is example for nylon. And last one is a stereospecific polymer arrangement. The functional groups are arranged either orderly arrangement or disorderly arrangement is called as stereospecific polymer, that are further based on nomenclature. So classification of polymers. Polymers cannot be classified under any one category because of the complex structure, vast application. So that's why one we are telling us based on origin. There are three types. That is natural polymer, semi-synthetic polymer and synthetic polymer. And based on nomenclature, 5 types: homopolymer, heteropolymer, homochain polymer, heterochain polymer and stereospecific polymer. Types of polymerization reaction. This polymerization reactions are mainly two types: addition polymerization and condensation polymerization. Addition polymerization or otherwise is called as chain group. Condensation or otherwise is called as stepwise. So already we have studied for what is polymerization reaction. So what is polymerization reaction? It is a chemical reaction. Monomers are combined to give the polymers with or without elimination of small molecules like water is called as addition, is called as polymerization reaction. Now we will see that addition polymerization reaction. So what is addition polymerization? Addition or otherwise is called as a chain group. So what is addition polymerization reaction? It is a chemical reaction that yield a polymer which is an exact multiple of original monomeric molecule. And the original monomeric molecule contain one or more double bond, and it does not eliminate small water molecules like water or HCl. So that is called as addition reaction, addition polymerization reaction or chain growth polymerization reaction. That is, it is a chemical reaction that yield a polymer which is an exact multiple of original monomeric molecule, and original monomeric molecule containing one or more double bond and does not eliminate small molecules like water or HCl. So example for addition polymerization: ethylene in the presence of heat, pressure and catalyst, we can get bifunctional monomer. Is called as bifunctional monomer. So already we have studied that functionality. So bifunctional monomer is functionality is 2, and we can get polyethylene. example, vinyl chloride undergo the polymerization in the presence of heat, pressure and catalyst. We can get bifunctional moreover. Then the final product is PVC. So what is PVC? It's a polyvinyl chloride. So another example, acrylonitrile. So acrylonitrile undergo the polymerization in the presence of heat, pressure and catalyst. In the presence of catalyst, we can get the bifunctional monomer. So we can get pan. So what is an expansion of pan? Is polyacrylonitrile. So that are the example for addition polymerization. So the addition polymerization, so ethylene undergo the polymerization, we can get polyethylene. Vinyl chloride undergo the polymerization, we can get polyvinyl chloride. Acrylonitrile undergo the polymerization, we can get polyacrylonitrile. So the polymers are polyethylene, PVC and pan, and the monomers, polyethylene monomer is ethylene. PVC monomer, vinyl chloride. Pan monomer, acrylonitrile. So acrylonitrile polymer, polyacrylonitrile. There is a vinyl chloride polymer, polyvinyl chloride, and ethylene polymer, polyethylene. So that is called as addition polymerization. Next we will see for the condensation polymerization. So condensation polymerization reaction, it is a chemical reaction between a simple polar groups with the monomers, and formation of polymer is known as condensation polymerization. So example for condensation polymerization is nylon. So how do you form the nylon? Hexamethylene diamine. So 2 amine groups, 6 molecules of methylene. So hexamethylene diamine. Hexamethylene diamine reacted with adipic acid and removal of water molecule. Is adipic acid and removal of water molecule 2NH2O. We can get nylon 6:6. So 6:6. So the 6 stands for number of carbon atom. So this is for the condensation polymerization with the elimination of small molecules like water. Hexamethyl diamine reacted with adipic acid, removal of water molecule, we can get nylon 6:6. So another example for condensation polymerization, nylon 6. That is just opening of cyclic compound. Example is caprolactam. undergo the polymerization without elimination of small molecules. First we discussed with the nylon 626 with the elimination of small molecules like water, we can get nylon 626. Now without the elimination of small molecules, just opening of cyclic compound. So we can get nylon 6. So that are the example for condensation polymerization. So what is condensation polymerization? It is a chemical reaction between a simple polar groups containing monomers, formation of polymer with or without elimination of small molecules like water. So elimination of small molecules like water, this example is nylon 626. So to how you form the nylon 626, hexamethylene diamine reacting with adipic acid, removal of water molecule, we can get nylon 626. And another one without elimination of small molecule, example is a caprolactam, undergo the polymerization, we can get nylon 6. So just opening of cyclic compound. So that are the example for condensation polymerization. And what is the difference between addition and condensation polymerization? So the addition polymerization is the chain growth polymerization, and condensation polymerization is called as a stepwise polymerization. So for that you have to take that comparison or differentiate for addition and condensation. So addition polymerization is called as a chain growth polymerization, whereas a condensation it is called as a stepwise. And second point, so polymer is obtained without elimination of small molecules like water or HCl. Here condensation, the polymer is obtained with or without elimination of small molecules like water or HCl. With the elimination of water molecule, that example is nylon 626. Without elimination of small molecules, that example is nylon 6. So how do you form nylon 626? Hexamethylene diamine react with adipic acid, removal of water molecule, we can get nylon 626. Nylon 6 without elimination of water molecule, just opening of cyclic compound, caprolactam, example is caprolactam, we can get nylon 6. And another one is exact addition polymerization is exact multiple of original monomeric molecule. For condensation polymerization without exact multiple, because sometimes elimination of water, sometimes without elimination of water molecule, the polymer is obtained. And here homo chain polymer is obtained for addition, homo chain polymer is obtained for condensation, hetero chain polymer is already we have studied homo chain and hetero chain. What is homo chain? The main chain of polymer is made up of same species of atom, carbon, carbon, carbon. That is called as a homo chain. And condensation, hetero chain. So hetero chain are different atom, carbon, carbon, nitrogen, oxygen like this. So carbon and nitrogen. So condensation polymer is example is nylon, because the main chain of polymer is made up of more than different type of atom, more than one type of atom. It is called as condensation polymerization. And the next one is this is addition polymerization are called as a thermoplastic, and condensation are called as a thermosetting plastics. And next comparison for addition polymers. Polymers are product, polymer product is formed immediately, whereas condensation polymer product is formed stepwise. And write an example for addition polymerization. Example polypropylene, polyvinyl chloride, polystyrene are example for addition polymerization. And example for condensation polymerization, nylon. So there are three nylons are there: nylon 626, nylon 6, and nylon 11. And PET, the PET is polyethylene terephthalate or polyester is another name for PET, polyester. Another next one example is polyurethane. So that are example for condensation. That are the difference between or comparison between addition and condensation. So far we have discussed about that polymers. So what is polymers and what are the different types of polymers and what are the terms used in the polymer chemistry, that is what is degree of polymerization, what is the functionality and what is the tacticity, and what about the classification of polymers and what are the classification of polymerization reaction. So polymerization reaction, addition and condensation. So what are the classification of polymer based on origin and based on nomenclature. Based on origin means natural polymer, semi-synthetic polymer and synthetic polymer. Based on nomenclature, homopolymer, heteropolymer, homochain polymer, heterochain polymer, stereospecific polymer. So define functionality, define degree of polymers and define that tacticity. So that are some of the important terms we discussed in the polymers.